everyone, and welcome back to the Science Data and Analytics track. Next up, we have Jaimin speaking to us about building interactive dashboards using Streamlit. Jaimin is a data scientist and software engineer working in the field of data science and machine learning for the last 3+ years. Really looking forward to this talk. Take it away, Jaimin.
Thank you. Good morning, everyone. Welcome to the talk Streamlit. Today, we will be covering the basics of the Streamlit module, and then we'll have a follow-up by building a live demo on how to build an app using Streamlit. So let's get started. Before we begin, let me give a brief introduction about myself. I graduated from DICT with a BTech honors degree in Information and Communication Technology. Since then, I have been working as a software engineer and a data scientist at a company called Infocus Innovations Private Limited. Infocus is a consulting company providing ML solutions in various disciplines. Over the past 3 years at my journey at Infocus, I have worked on various projects with different international clients ranging from software engineering, data science, and cutting-edge ML algorithms. Please feel free to contact me using the details mentioned in the slide. So today we will be first covering an introduction to Streamlit, followed by covering the main concepts and components that it provides, and then we will have a live demo on how to build an app using Streamlit. So let's get started. Now, as a developer, you all must have a question. Why was there a need for Streamlit? The question seems appropriate, and I have an answer for that. The inventor of the Streamlit module felt that there was no easy-to-use Python module which can be used to create web apps to present ML results or business or data insights. To make it more clear for you, let's take a look at some of the comparisons and alternatives. The first one is the Jupyter Notebook. As a data scientist or ML research engineer, you must all have heard and used Jupyter Notebook, but it is not a good way to deploy it in the production. The second option is Dash by Plotly. So this is a very good option if you want to build aesthetic looking web apps, but the only downside is that the developer needs to have a prerequisite knowledge about HTML and CSS. The third and the last and the most preferred option that I have seen deployed in production is the use of Flask framework. Now, there are many levels of abstraction in the Flask framework, which makes it difficult for the developer to use it if he or she doesn't have the knowledge for that. So now let's take a look at how Streamlit can be used for different purposes. In this video, we'll go through an app which analyzes the data for the Uber pickups in New York City. So by clicking the checkbox, we'll first look at the raw data that is available to us. And using the slider, the end user can switch between the hours 24-hour range and check the heat map of the various regions in New York City for the Uber pickups. And in the histogram down, we can see the number of pickups per minute in that hour selected. Next, we will see how Streamlit is used for model inference. Here, we're covering the object detection inference using YOLO v3. Now, as you can see that I'm asking the model to detect car from the frames in the videos. Next, you can choose the frame number for the video using the slider provided in the sidebar, and we can see the output. Moreover, you can play around with various hyperparameters just like how I clicked on the slider to see how the model performs when we change that. So now let's talk about the main concepts of Streamlit. The first point is it embraces Python scripting. So the developer need not know any other language or any other knowledge about the same. He can build the total app using Python. The second point is immediate and interactive live environment. Streamlit provides very rich interactive widgets through which the end user can interact with the web app, and moreover, for the immediate output, whenever you save the code, you can see the live output when you save the code in the web browser. The last point is that the Streamlit re-executes the script from top to bottom whenever something changes in the code. So let's say the developer saves the code by changing something, or whenever the end user interacts with the web app and changes a value or something, it executes the whole script again in the top to bottom manner. So now there would be a natural question that comes to your mind. Wouldn't that slow down the app? So I would say that is a valid question, but Streamlit has covered it. It has a mechanism through which it makes the rendering of the web app faster when there is such a scenario. So it is a simple term that every computer scientist must have heard during his or her knowledge in the computer science field. Yes, the answer is caching. Streamlit provides the functionality of caching so that the developer can skip the data fetching and loading as well as the heavy computation part. Moreover, it also provides this functionality in the Pythonic way of using a decorator. So basically, you can just write at st.cache on top of your function that you would like to get it cached. However, to get your function cache, Streamlit checks for some of the conditions. Let's take a look at them. So the first condition is the input parameters passed to the function. So now let's take the help of an example code snippet and check that. As you can see in the snippet, we have a function called compute exponent that we are trying to cache. Now, if you take the look at the last second line, we are calling that function with the parameters a and b. So those are the input parameters. So if you change the value for those parameters, the function won't be cached in the subsequent run. The second condition is the value of external variable used in the function. So now if you take a look at the code snippet, you see that there is an external variable called exponent used in the body of the function compute exponent. So if the value of that variable changes, the function won't be cached. The next condition is the body of the function. So whenever the developer changes anything in the body of the function compute exponent, the function won't be cached in the subsequent run. The last condition that it checks is the body of any function used within the cache function. So for our example, we can see that we have another function called multiply that is used inside the function compute exponent. So if we change the body of that function, then the function compute exponent won't be cached in the subsequent runs. So now let's take a look at some of the components that the Streamlit provides to build the web app. Today, first I would like to talk about a single function st.write which can be used for multiple purposes. So as a developer, you would like to flush out various kind of data to your web app. So now you can use this function st.write and flush out any form of data. If it is text, data frame, tabular data, plots, graphs, anything, you can just use this single function and you can achieve the functionality of flushing out your data using that. Moreover, if you have used Jupyter Notebook, you would have worked with the Markdown, and you can use that here as well, as Streamlit provides the functionality for that by calling the function st.markdown. Moreover, if the researcher would like to present some mathematical equation or anything else in the LaTeX form, Streamlit provides the functionality for that as well. You can call the function st.latex to achieve the functionality to write LaTeX. Next, we look at some of the widgets that the Streamlit provides for the users to interact with the web app. So we will look at some of the interactive widgets that make it user friendly for the end user. Text input. So here the end user can type in anything and the web app will use that for its purpose. Next is the slider. As we have seen in the previous videos, slider allows the user to select values in between some of the numbers that is already been specified. So there is a min value and a max value and the user can choose in any number in that range. Checkbox. Checkbox is like an on-off switch which you can use whenever you want to write it out something using a condition. Select box. Select box is essentially a drop-down menu. However, you can use it in two ways. First one is a single value drop-down box, and the second one is a multi-value drop-down. So it would be really good if you can use this so that it makes it more user-friendly for the end user. The last component that we will be looking today is the sidebar utility. So the Streamlit provides the sidebar utility as we have already seen in the previous video. where it allows the end user to interact with the web app using the widgets that are there in the web app. So the developer can put all his widgets in the left hand side panel so that the end user gets a more cleaner and focused look for the web app. Now that we have looked at the main concepts and components of the Streamlit app, let's get to the live demo that we would want to have to build an app. So before we get to the demo, let's first install the Streamlit module. You can install the Streamlit module by just writing a single statement: pip install Streamlit. The only requirement is that it requires Python 3.6 or higher. After you have installed the app, you can run the command streamlit hello to check if everything is working fine. It will open up a web browser where you can play around and see various demos that it provides. So now let's get to the demo where I will be live coding an app to build a fully functional app. So if you check out this repository that I have mentioned in the slide, all the resources have been committed and pushed there. So before we get to the coding part, let's first take two of the demos that I have built to show you guys. The first one is where I plot the closing price of tickers in the New York Stock Exchange. Now, as you can see, I have a checkbox which says show the data frame. Now, if I click on that, I'll get a tabular output which has the raw data in the tabular form for various tickers, and there are some of the fields that denotes the prices. As we can see, we have a drop down or select box here where we have chosen the SPY as the default ticker, and I have plotted the closing price for that ticker. Now we can play around with the drop down menu and select other tickers and see the output in the plot below. So the next app that I would like to show is the model inference app that we would be live coding today. So here we are trying to predict the flower type of the iris, that is a well-known dataset in the ML field. So there are four features for the dataset that are mentioned on the left-hand side panel here in the sidebar. Now the user can play around with those four sliders and see the output of the model. So what the model predicts the class to be. So if I change the output of this value, we can see the model predicted the class Virgin car. Moreover, we can change and see the output of the model varying with the varying inputs. So today we'll be making a clone of this app on this talk. So let's get started with the demo. So this is the first boilerplate that we will be using for any of the Python script. Nothing new here. So first we need to load the data of the iris that we are going to use for that. I'll be importing sklearn so that we can load the data set easily. So now we have loaded the data using the inbuilt module that we have loaded. But now, as we have seen in the earlier slide, so we can use the functionality of caching as we using the same data throughout our web app. So we can place the decorator st.cache here. And first, let's put a markdown value so that we can see what the web app looks like. Iris flower prediction app. So whenever you change something in the code and it's the first time, just click on always rerun so that you get the output whenever you save the code. So I just typed in this and we have the output here immediately. Let's write a brief description about the same. So this app predicts iris based on the given user inputs. Now we can have the model inference, but currently we will train the data set here as well. But you can load the saved model that you have built directly here. For training the data set, we will be using the decision tree classifier. So the decision tree classifier in itself requires a talk on itself. We won't be going into details of that. We will be just using the decision tree classifier right now. Calling the fit function, we are basically training the classifier, and then we can use this train classifier. So let me return that train classifier here. So we just need to train it for one time. So we can use the functionality of caching here as well. So now let's build the sidebar. So now when I save this, we can check the output here. So it says user defined inputs in the sidebar. So now let's add the sliders that we saw earlier in the demo. Basically, we will be just looping through all the features and names, and we will be assigning the name to the sidebar value and the minimum and maximum value for the slider. So Now the slider function has four arguments. The first one is the name that you would like to assign it to the slider. The second is the minimum value. The third is the maximum value. And the last is the default value of the slider that you would like to keep. So by default, we are keeping the median of the feature as the default value. And now the value variable will have the value that is selected by the user for the slider. So we will be adding it to the global variable feature so that we can combine all the values from the all sliders and then pass it to the train classifier so that we can predict the class of the app. So now that we have the feature, let's output it. Convert it into a numpy array so that it will be helpful for us. And as you can see here, I'm using the same function st.write for outputting text as well as the numpy array. So let's now just predict using that feature. We can call the function classifier.predict and we pass in the feature. It will return a 1x1 numpy array. So I'm just taking the first index for that. Now this will be an index and not the actual class name. So in order to get the actual class name, let's write the logic for that. So now we can play around with the uh, slider and see the output for itself. And I would just like to add one last thing before we end the demo is to add another functionality. So yeah, we have coded the live app using Streamlit. So we are all done with the demo. I hope you would have liked the demo and you can use it, the Streamlit for your own purpose. You can check out all the resources in my repository that I mentioned here. Moreover, these are some of the references that you can use and play around with the Streamlit by using these resources. Thank you.
Oh, thanks, Jaimin. That was a great talk. There was quite a lot of discussion, and people seemed really impressed with Streamlit. I think we only have one time for one question, and I just saw a question that came in about how do you refetch a data source in Streamlit?
So how do we, can you repeat it? How do we fetch data?
Yeah, refetch a data source. So if you have a data source and it updates, how do you refresh the data?
Yes. So if the data is refreshing, we might not be able to use cache for it. But so let's say you are using some kind of database or you have hosted it somewhere, you can simply connect to it and use it by using the correct libraries or modules for the same.
Great. Thank you once again, Jaimin. I think that's all we have time for today, but head over to the chat and I'm sure there's more questions there for you. And thank you again. For everyone, we have a long break now before our next sessions, just a bit under an hour. I think we're 50 minutes actually. So we're back at 12:45 Adelaide time. So see you again. Bye.